te dit à quand tu dois arrêter, enfin,
20 minutes.
dans 20 minutes.
10-20 minutes.
20 minutes.
Okay. I guess we can get started, right? So, let me just say a few words about myself before I get into the meat of this talk. I'm Géry de Bonny. I'm working on the JavaScript framework for a long time now. And today I will not talk to you about Odoo really that much. Actually, there is a good chance that my talk is not really useful to you. It will be more like interesting, I hope so. I will talk to you about one of my, let's say, I won't say hobby, but one of my really interests for the last few years, and it is how to render efficiently a user interface. And the key word here is efficiently. Because rendering a user interface, it's easy to do it in a slow way, no problem at all. The question is how to do it fast. And unlike sports, in sport you need to do a lot of work to be fast, I guess. I'm not very good at sport. But for computer, the name of the game is to do less work. That's the way you make it fast, of course. I forgot to say, you have those, this pad. You can write some questions if you want, obviously, and I will try to answer them at the end of this talk, and then maybe we can talk after if you want to. Okay, so we want to talk about rendering, but before that, let's have a few more about JavaScript frameworks in general, because there is some point that I want to make. The job, you could say that the job of a JavaScript framework is to turn some kind of description of user interface and some state into a real live user interface, which means HTML elements, not a string. That's a key part of the that I want to make. You need event handlers. You need your interface to react to the user interactions. Okay, so that's really a very high-level description of a JavaScript framework, and pretty much all JavaScript frameworks have to do this in a way or in another. You know that at Odoo we talked about. Sam told you about the OWL framework, so I won't talk too much about that. I think I have, yeah. So OWL is our custom built-in framework, and it's made for Odoo using our own needs as a guide to what we want to do. So I will use, of course, OWL as an example, but what I'm saying really applies to pretty much all frameworks, and more specifically to virtual DOM-based frameworks. We'll talk about that just in a moment. Okay, so I think that I want to tell you about templates first. And a template, you'll think about templates as probably as some kind of XML element, XML documents like this, or maybe JSX, or maybe a Vue template. They all have their kind of language. They all have their own rules, and all of those are description of what you want to achieve. They are not really executable code, and all frameworks have, in a way or another, to compile those templates into a function. And that's what this function does that interests me. The function is taking some state, some context, some rendering context, and we'll do something about that. And now the big question is, what does it do? That's what I'm going to talk about. So, as I told you, we want to create a rendering, we want to create a user interface. I will say the DOM. If you don't know much about JavaScript or about browser, it's fine. Let me just explain what DOM means. DOM is kind of, it means document object model, but basically it means the real HTML that you see displayed in the browser page. That's what DOM is. That's important to know. So I will probably use that sometimes instead of HTML elements, or that's really kind of a synonym. So, rendering a user interface, you have one common workflow is to take some states and then create those HTML elements and those event handlers. You create your user interface. So that's one thing that you have to do. But unlike server-side rendering, you need to do something more. You need to update your user interface. Whenever your user is doing something, maybe typing something, or maybe clicking on a button, whatever, it usually it triggers a state update. It will change some internal state of your framework, and that will, in turn, will trigger an update of your user interface. And there is something very, very important here. This update operation cannot be done in a naive way. You cannot just scrap away the existing DOM and you replace it by a new copy of your HTML, a new DOM. If you do that, you would lose a lot of your state. For example, if the user was typing something in an input tag, you see, he was typing a few letters, and then something happened, and you replace his input tag by a new one. What he was typing in would disappear, obviously. It's the same if he was selecting some part of your web page, or if he was scrolling down. If you replace just naively the content of the page by a new one, you would lose that state. So really, the update operation needs to make sure that you keep the existing elements that you have present in the DOM as much as possible. You need to just pinpoint those updates that you need to do. You need to change maybe some CSS class on this HTML element, or maybe just remove some part of the DOM and replace it by something else, but the rest should keep the same. So we have two paths, create and update. And that's really the key difference between browser and JavaScript frameworks and rendering engine that you can find on the server side. Those rendering engines just have to generate as fast as possible an HTML string, but JavaScript frameworks have to keep the same HTML alive. That's the main difference. So now, how do you render your user interface again? We have actually many ways to do that. There is not just two rendering strategies, but I'm talking about those two because they are the main one that came to mind when I studied this topic. The first one is to make the template function do the two operations, create and update in one function, in once. So basically your template function will take your state, generate some HTML elements, and then maybe it would register some listener to state changes, and then will trigger those state changes would trigger targeted updates to your DOM. That's one strategy. In that case, your function would be called just once. You cannot call it more than once. If you do, you would generate two copies of the DOM. But it makes sense. You could do that. Another strategy, and that's the one I will focus more out, is to move those create and update operation out of the template function. So your template function would then generate some intermediate representation, some in-memory visualization of what you're trying to show, and then the underlying framework would do the actual work of creating and updating the real DOM. And this intermediate representation, it's commonly known as the virtual DOM. A virtual DOM is not the real DOM, that's just what it means. It's something that exists in memory. It's basically a tree of objects, and I'll show you just in a moment what it is. So when you use that strategy, your template function is much simpler. It doesn't care about how the state should be observed, how to update the DOM, even how to create the DOM. It doesn't care about that. What it does care about is generating that virtual DOM. It has one job, and it can do it quite simply. So, and also, if you look at the generated code, it will map much closer to the actual template that you probably wrote at some point. Okay, and then, so the framework then has to use that virtual DOM that you generate and use it to create HTML, and then later it has to compare two copies of this virtual DOM and see what the difference is, and then we'll apply those changes. That's what a virtual DOM does. So basically you have two phases. The render phase, where you generate this virtual DOM, and the patch phase, where you reconcile the DOM. You compare the old version and the new version. You basically traverse the complete tree, and you look at each tag, each attribute, anything to see what changed, and then you patch that. And I have here a common API for a virtual DOM. You have a mount function that will do the initial creation operation, and a patch function that will compute a diff and apply it using old tree and new tree. And you have many variations on that topic. You can keep reference to the actual DOM node inside the virtual tree, so you can access the DOM faster. You can do a lot of stuff to try to make it fast. But really, at the end, that's what it does all the time. So now, the question, of course, the $1 million question is, which one is best? Should I use a virtual DOM or not? And again, most of the time when you work in engineering, you will have the real answer will be it depends. Maybe, maybe not. It depends on your use case. I will not go through all those points because I don't have that much time. But I want to say that virtual DOM are known to be slower, and I want to come back to that in a moment, of course. But they are more convenient for some other reasons. They can allow splitting rendering operation and patching operation, and it's nice for some situations. And they have a lot of interesting properties. So the question is, which one should we use? And it's not clear. And historically, all those mainstream frameworks, they tended to use a virtual DOM because it was kind of neat to use. It's simple to write. You can do it in an afternoon. A naive one can be done quite quickly. And you have React and Vue are virtual DOM based, and OWL as well. Now, the virtual DOM-less approach is kind of new. It was not performant enough in the past. Now it's been shown by Solid Framework and Svelte that it's possible, and then you can get very good performance out of that as well, using signals and effects and other IDs. So I would say both approaches work. They have different set of trade-offs. For OWL, we decided to use the virtual DOM, but you have a small twist, because to that question, are virtual DOM really that slow? We have an interesting answer. And this answer, okay, first I want to explain why it's slow. As I told you, a virtual DOM is really a big tree in memory. So it looks like this. It can look like the way you want, of course, but traditionally it would look like this. You have a list of objects which contain children, a list of children which are objects which contain themselves children and so on. And they all have tag name, attributes, and maybe event handlers. This is this button as an event handler. And just look at this HTML or this template. So every time you render your template, you get something like this. Now, that's why basically virtual DOM are known to be kind of slow, because every time you render your template, you need to generate a tree like that. Every time. You don't have a choice every time. And it's actually bad for garbage collection. For example, if you have a lot of small objects, then it will just trigger garbage collecting path very quickly. So it's not so good. Also, the patching phase will be slower, obviously, because you need to traverse that tree and then generate an HTML element for the outer div, then set its attribute, then generate another div element for its child, attach it to the parent div, and then generate the proper class, and then do that for every element individually. That's why it's kind of slow. Okay? So, the question is, how can we solve that? Because we're doing a lot of useless work. If you look at this template, by the way, I will always take the same template. All of them are the same structure, so it's easy to compare. So if you look at this template, what you have here is basically 3 dynamic elements. There are only those 3 boxes that can change. You have an if condition. So this if means that this div may or may not be present in the result. You have a dynamic text node, a title, and you have an handler that may or may not change. We don't know, but it could. So really, when you use a traditional virtual DOM approach, you need to go through all of that, and then you will compare all div, all tag name, all attributes, all text content every time, and that's wasted to work for half of these templates, maybe more. So that's where I come from with this idea, the block virtual DOM. So that comes from a research project I made 2 years ago named Block DOM. It was an experiment in avoiding that wasteful work and to try to get the advantage of a virtual DOM, but without the overhead. And how can you do that? The main idea is that this template that I showed you, or any template for that matter, you can split it in structural blocks. And you try to work on those blocks in one step. You can clone them in one step. You keep a reference to a template, and you can clone them in one step. And doing that, the goal is to avoid diffing any static value. Basically, what you compare are just the dynamic values, not the static values. And by doing that, you would get much better performance for most use cases, and at the worst case, you would get a performance equivalent to a traditional virtual DOM, because you would have to compare everything if everything is that dynamic. So let's come back to this template again. This template can be, if you look at it, divided in 2 blocks. You have, structurally I'm talking about that, you have a T-if, so that means that the content of the inner div may or may not be there. And the way a block DOM would work, it would understand the outer div as one block, and you can see I have like a block all one that I inserted instead. So from the point of view of block DOM, this is just one block, and the inner block is another block. And the inner block has 2 dynamic elements, some handler and some dynamic text. So what block DOM will do, it will just make a copy. It will generate a template HTML element for those 2 elements, and whenever that block is required, it will just clone that in one step. But let's look at this, at what it means. When you render your template, you don't have to render the tree. You don't care about the tree. You only care about the dynamic part. So what you care about is the fact that your main block has or has not a sub-block, and you care about the 2 dynamic values, the text node and the handler, the click handler. That's the only thing you care. So when you render your function, your template, I mean, you just need to collect those dynamic information and assemble them in a simple tree which has 2 nodes, or 1 or 2 nodes. So this is the compiled code for a block DOM template, all templates, let's say. It's not very sexy, of course, but if you look at this, you really basically you have a closure, and in that closure we generate 2 blocks, and what it does is that it keeps in memory a reference to a template element that will correspond to this block, and same for the second block. And then when you call that closure, it will return a function, and that template function is a template that will be used and will be called repetitively in the future. And that template is quite short. It gets the dynamic value, compare them. No, it doesn't compare them. Sorry. It just checks the condition if there is a sub block or not. If there is no such block, it will be very fast, and it just do the work on those dynamic values. And so basically we delegate we have a fast rendering operation, because the rendering operation only applies to the dynamic values. And then we delegate to block DOM the fast DOM updates, because when you render, you don't care about the DOM actually. You just care about the values. And once you want to patch that to the actual DOM, you ask block DOM to do it, and block DOM will clone in one step and will apply all the dynamic value at the proper location. I don't have much time, but it's fine. I'm almost at the end. So the question is this approach fast? Are block virtual DOM much fast? And the answer is, of course, yes, they are. Since block DOM was introduced 2 years ago, I published a benchmark to a JavaScript framework benchmark project. And at least 2 other projects now implemented the same approach since then. And you can see those 3 rows over there. They give you the 3 top performing virtual DOM in the world. Those are all 3. They are based on the block virtual DOM approach. So yes, this is a very fast code base, very fast ID. And let's talk about this question. Are block DOM the future of frameworks? I'm telling you that, I'm telling that you're wonderful, but really, will they be used in the future? Well, I don't know. For some frameworks, maybe. It would make sense for basically all virtual DOM-based frameworks to go to that kind of optimization. So OWL is using them. React has there is a project named Million.js that uses the same ID on the React ecosystem. So maybe you'll see more about block DOM in the future. We'll see. Anyway, my time is up, so thank you for your attention. You can ask questions on the pad. I hope you have had the opportunity to read the URL. So let's see. There are no questions for now. So. Okay, there is one question. Is my work on block DOM posted on GitHub somewhere? Yes, you can check my GitHub repository. There is a block DOM project, and you can just look at the code. Or maybe you can look at the implementation on JavaScript Framework Benchmark project. Okay, well, thank you for your attention. If you want to ask me questions, you can try to find me somewhere. I'll be around. Thank you again.